We are moving on to our student innovators and startups. So we have traveled around the world. We've heard from Canada. Where else have we heard from? We've heard from Israel. And now we fly to Indonesia, where we will hear from our first student innovator pitch. Daihatsu is interested in learning about how can we accelerate the transition to becoming a carbon neutral automotive manufacturer in Asia. And we have a student here who thinks he has the solution, and he would love to present your idea to you. So, hello, can you hear us okay? And can you share we can see your screen. Can we hear from you as well?
Can you hear me, Ashley?
Hello, Privio, welcome.
Hello.
Please take the stage, it's yours.
Thank you. First of all, let me introduce myself. My name is Previa Prakasa. A little bit of background story about this idea. I am from mechanical engineering. My graduate degree. Uh, before my bachelor thesis actually surrounds the manufacturing of a composite material using 3D printer. And what I found is that if I have a really sophisticated 3D printer with a sophisticated modification, it's very hard to outsource a place to actually do printing. And even if I can make multiple printers, it's really hard to actually control all of them. So what I found in this case is this: the problem with 3D printing is one is 3D printer is very slow. And if we have a massive amount of 3D printer, it's very hassle to control. It's almost not impossible, basically, but it's not really a feasible solution. And if we have also imagine that 200 3D printers actually idling, it's very much inefficient in the sense of power consumption because it continuously running. And the solution is here is that why not we make a supervisor ecosystem for this 3D printer, hypervisor in this case. So this solution not only integrates into the ecosystem on your production line or in manufacturing, but also enables scaling on the 3D printing capacity itself. So there's three key points on this ecosystem is that one is data driven. Second is the modularity of the technology and scalability of the ecosystem. The inspiration that I was actually got from the for this technology is from Docker or Kubernetes, if you are more familiar with it. It's essentially a virtualization of operating system. And if you have an app and you have a really big load, Kubernetes or container, in this case Docker, will automatically scale up the needs for the client and essentially reduces the consumption of the thing. The modification is very simple. It's just 3D printer combined with a single board computer or anything in that regard. So not only that this 3D printer can allows communication between main server, but also it has the capacity to actually have sensors or anything, and the turning off the 3D printer, for example, and essentially collecting all the data needed from the clusters of the 3D printer, or in this case, the containers of 3D printer, but it's physical. And essentially, in the conventional way, 3D printing pipeline workflow is very, very needs human intervention. Start from the CAD model to STL conversion, and then slicing, which is uh, switching between softwares. And in this sense, you can actually automate in the blue box that I've shown you here, where the whole thing can be just done within a main server or main processing unit. And it will automatically queue up all the printing needs and essentially will choose a correct printer based on the operator where it actually needs to be. So it is actually very low energy consumption of this technology because if the printer actually doesn't really need anything, it doesn't really do anything, it will automatically turn off instead of idling. And because of its data driven, the 3D printer itself will have its own some sort of status on how much it's filling and the essentially the automation of the main server will make sure that it will evenly distribute it across the clusters. And it enables operators to supervise remotely even how the printer is going and everything else is actually going on within the production line. And the modular integration with this in case, if the client actually wants to have robots to fetch the 3D printer, for instance, or have an air conditioning unit to actually climatize the room, it can be integrated with any kind of a direct link with the main server because we already have the data. I imagine if I become a startup, I will actually provide the services for installation, consultation, and any kind of modification for the printers that actually need it. And the development stage, it's pretty much a lot of research actually need to be done with what kind of 3D printer actually compatible or any kind of 3D printer actually already compatible and have its own smart system essentially. And that's all from me, I guess.
Thank you so much, Preview. I apologize to the judges. We heard the pitch from Previo. He is working with Isuzu, hoping to work with Isuzu. And his question is, how can we introduce new manufacturing technologies, such as 3D printing, to using in clean energy in car manufacturing? So apologies, it's not the statement that I had written here, but he was talking about 3D printing. So please open to the judges. Are there any questions? Yes, Victor.
Previo, first of all, great job. And love your idea about the agile approach in virtualizing 3D printing. It's a little unclear if you were to take this to a business, how are you going to make money? Right? Who are you charging? And how are you charging?
So thank you for the question, first of all. I would imagine actually I would supply consultation and installation and any kind of modification actually need for the customer. And my target customer is actually startups. They're actually starting to forming 3D prints, for example, or any kind of manufacturer companies that wants to have a production line that actually requires 3D printing. And this 3D printer actually can be anything, FDM with polymer filament or even SLS with a metal print. I would imagine that.
And Privio, have you tested this on any materials? I mean, there's plenty of sort of medical device people who do 3D print titanium knees, and they're serious materials. Does this work on every material?
Yes, in theory, or it's actually can be implemented to any kind of 3D printer available, as far as that 3D printer actually have the capability to, for example, communication to UART or USB or LAN cable. Essentially, any kind of 3D printer, any kind of material can be integrated with this kind of system. That's the main goal of this, why it's called hypervisor.
And do you think it... Sorry.
Jonathan, go ahead.
Sorry, I was going to say, are there other similar kind of systems out there, or is yours really groundbreaking?
It's actually already a system that actually are out there for forming and essentially having a main server to control all the printing. But I'm here to fully optimize for like bigger companies that actually need a robust ecosystem.
Thank you very much, Privio. All right. We'll see you a little bit later. Thank you very much. Thank you.
Thank you very much.
All right. And now we do talk to our team who is interested in learning about how we do accelerate the transition to becoming a carbon neutral automotive manufacturer in Asia. Daihatsu is the business unit that's put forward the statement, and we invite David from Italy, who will share his idea with us. David, can you hear us and see us okay? We can't quite see you yet or hear you yet. Wonderful. We see that you're sharing your screen. Can you say hi and turn on your camera, maybe? Hello. Hi, we see you. Wonderful.
Hello.
Hello.
Hello. I don't speak English. Speak for me, Din Halam. Okay.
All right. Din, maybe we'll hear from you. Can you turn on your camera and a microphone, please?
Okay.
Hello, everyone. Hello.
Hello.
Oh, hi.
Hi, we hear you, but very softly. Hello.
Yeah. So can you see my screen now?
Yes, we can see your screen and we can hear you. We'll turn up the volume a little bit in here. And
Okay.
please start.
So
We'll have a timer. Thank you.
okay, thank you. Thanks for joining us today. So I'm the co-founder of Heterodial. Heterodial is a solution. It has alternator without the stator. It has two rotators rotating against each other. It has the capacity of generating 3 times more energy if you compare with the normal alternators. So what is the problem? What why this solution. Currently, the electricity production is still from fossil fuels, especially from developing countries, and of course in USA and some other countries. But in Europe, they are developing new technologies to reduce the use of fossil fuels. The high rate of harmful emissions comes into the air if we use the fossil fuels
Din,
as an
apologies.
energy source.
Apologies. We can't quite
The
hear you, Din. Maybe if you can come closer to the mic or try something a little bit different. I think we're having a hard time hearing you in Hong Kong.
Okay, so can you hear now?
Much
Is
better.
it better
Thank
now?
you very much. Yes, please continue.
Okay, so the electricity production is still from fossil fuels, especially from developing countries, and of course from Europe. But the Europe has initiative to stop using fossil fuels in 2050. The high rate of harmful emissions comes into the air because of the using of fossil fuels and so many other issues. So the total available market in the electricity vehicle market is 246 billion, whereas our serviceable market is 81 billion. The sports car industry, it has a 31 billion, where the serviceable market is 10 billion for us. In the general car industry, it's 1445 billion, whereas the serviceable market is 411 billion for us. The renewable energy market is 881 billion, whereas the serviceable market for us is 325 billion. Our customer segments, the electric car makers will be really interested to work with us because it has the capacity to speed up the runnings of the car. And in renewable energy companies, they will be really interested to use this technology. Especially the EU and other government, they are interested about the sustainable development and sustainable to obtain the sustainable goal. This technology can really help them. Of course, in household, we can push this technology in households also. So, why us and why this technology and why it is the right time to
Hi, Din. Just a
to
quick question. Are you moving your slides? We're still on your first page title slide.
yeah, of course, I'm moving my slides.
Ah, we see it now. Why us and why now? But we were stuck on the first slide. No worries.
Yeah.
Please go ahead.
So why us and why now? It's cost effective. We can reduce the fuel consumption by 36% in our automotive industries in cars. If we use this technology, it can speed up the process by 3x. It's easy to implement, especially if we it can be implemented in areas like solar power and the wind energy. So it's we can uh, we can uh, we can produce more energy in the renewable energy market. It's environmentally friendly, and and we can be so how this can be implemented in different segments. Like in car industry, we can use this technology to speed up the cars. Like the suppose a car can run 50 kilometers with 2 liters of fuel, but with our technology it can be like 100 kilometers with the same consumption, like 2 liters of energy. It can be implemented in wind industry, like in turbines. Hello.
Hello, we can hear you.
Okay, so we can build and sell many or large wind turbines in different locations. Right now, it's the size of the wind turbines is a big problem. Also, that there is a big initial investment like 1 to 2 million euros or dollars to implement a wind turbines. But with our technology, it can substantially lower.
All right. Thank you,
Like
Din.
50,000 euros.
Thank you so much. I know we've had a bit of problem hearing you, but don't worry, our judges are on their iPads. They're looking at the information that you have submitted if the technology failed us a little bit on the sound side. So to our judges, do you have any questions for this team? Yes, Jonathan.
Yes, hi. I'm just wondering how far you've developed the prototype for this and to what extent it's been adopted or tested by businesses.
So we are working with Stanley Electronics. Stanley is one of the biggest group from Japan. They have a facility for they have a automotive in this automotive section. We are working with them, so we are testing we're testing the prototype in that. Hello.
Yes, we can hear you.
So we are testing the prototype in their factories.
Great. Thank you very much.
Can you just give us a quick, how does it work?
Yeah, of course. Can you see the screen now?
Yes, we can see this.
So if you see the left-hand side corner, the device looks like this. I hope you can see that.
Yes.
Yes, we can see that.
So when the when it rotates, maybe I can see a little bit.
All right. We can't hear you if you're speaking, but we can see your
Yeah.
screen. There you go.
So we have a double rubber clinging on the tire. So when the tire will compress an air cushion inside the cylinder, this will push the piston, pushes inside it with the outmost toothing. So it speed up the process of the tires. That's how it can be speed up by 3x depending on the cars,
All right. Thank you very
up to
much.
3x. Yeah.
Thank you very much. Thank you. Thank you. All right. Don't worry, our judges are busy on their iPads reading what they might not have heard. And so, with that, we will go to, thank you so much, the third student and innovator pitch. Again, we're inviting a student from Indonesia to join us. And the question that we're interested in hearing about is how can we provide renewable power solutions to replace fossil fuels and provide electrification through smart microgrids? All right, and so we have Muchamed, a student from Indonesia, joining us. Hello, hi there. Can you hear us and see us?
Yes, is my voice is clear?
We can hear you very clearly. Your timer is on the screen. Start when you're ready.
Okay. This is adult village. The electricity is fired by PLN grid. But if the organization arrive, the frequency power of the system will be the outage, and then this is the big problem. The main solution now are to implement the microgrid with the energy storage system. However, there is still some problem. My name is Muhammad Iqbal Sofyan. I will try to solve the problem. So the most common energy storage system nowadays is lithium-ion battery, but the cost is still too expensive. So we want to make a cheaper solution that we will use the lead-acid battery. But the lead-acid battery have disadvantage compared to lithium-ion battery because it has lower efficiency, limited cycle life, risk of discharge, slower charge rate, and low energy density. So the idea is to implement the XGBoost machine learning method and virtual inertial control technology to the battery control system of the US calcium battery pack. With the advantage is with microgrid system stability, advanced charge forecasting, longer battery lifetime, and stable charge and discharge rate. And after doing some research, I found out that implementation of the XGBoost programming logic to the FPGA and intelligent electronic device is the best solution to make GS calcium battery pack be the best solution for the PP battery. And virtual inertial control strategy is be used to make the microgrid have good stability like a synchronous generator. So the villager can sense the electricity like in the capital city, like in Jakarta or Hong Kong. And this is my solution. So it is same as the common microgrid, but with XGBoost logic, the FPGA we are now we will train in, and we will know when is the best time to battery pack to charge and discharge. So there is no wasting of battery cycle. Then the battery lifetime will live longer. And then virtual inertial control is used to make the solar panel output and GS calcium battery pack have as virtual inertia. And GS calcium battery can be the market leader because GS calcium battery is cheaper than active battery. The BCS has a virtual inertia to make the frequency maximal, and the implementation of XGBoost logic can help BCS to predict energy dispatch characteristics. And compared to electric solution, BCS is the best performance and most economic solution for microgrid because it has all the advantage of the solution before, and with the low cost of investment because the LCOE we get is about up to 2,000 rupiah per kilowatt hour. And this is why GS battery can be the market leader of microgrid controller because our solution is smart enough, and our solution is have lower cost than other solution. And this is the implementation plan. The first is to design. It takes 1 month, and then simulating our system 3 months, and then testing our prototype 4 months, and deploying the solution to the microgrid in Indonesia. It is a continuous development. So this is the business model. We will invite the local partner of who have the abandoned GS calcium battery to invest in us. They will get 40% of revenue per value of invested GS calcium, and we will build the microgrid and sell electricity through the microgrid, and we will get 1,000 until 2,000 rupiah per kilowatt hour. And this is our festival forecasting for 50 village case. So the IRR we get is 26%. And market opportunity of the microgrid in Indonesia is very big. So if you want to expand, there is a 31 billion US dollar market microgrid in Indonesia, and there is still 150,000 households in Indonesia. So that's all my presentation. Thank you for the time. Thank you.
Thank you very much. I think you flew through that. Our judges here are probably digesting some of your content at the moment. And do we have a question? Yes, we do, from Victor.
Hi. How do you scale? Because if I understand your technology correctly, right? You use lead acid battery, and so is there a limitation to space versus how much energy you can store and recharge?
Okay. So for the gate AC battery, the main concern is very high deep of discharge. So it is only have 50% of the optimal set of charge and discharge. So we can make the control system to assign. So we have some of GS calcium that is make array in series and parallel. So the BCS will can assign where is the GS calcium which is ready to charge on discharge, and to the solution for the space because GS calcium have lower energy density, so we can replace the shape of the battery storage container. It is can have more height and with the unique shape because this space is main concern, and for energy density, that is still a big problem because we must change the entire of the component or element inside the GS calcium battery. But in the development, I will first implement the XGBoost machine learning logic for this solution.
All right. Thank you very much for your answer, and thank you for your presentation.
Okay, thank you.
Thank you. We will speak with you shortly. Thank you very, very much. All right. Judges, we are almost there. We have 2 more students left, and you would have heard all 10 pitches after that. We are welcoming pitch number 9. We have a team called In My Palm with team members from Kenya, Indonesia, and China. And they're here to tell us their idea about how we can build a digital solution to foster partnerships with local communities while improving supply chain traceability. And this is with PAMA, one of our business units down in Indonesia. So, hi there, hello in my palm. We can see your screen. Maybe we want to turn on your camera and say hi, and also maybe we can hear you.
I have poor connection.
You have poor connection. Hi, Alan. Hello.
So I'll take you through our presentation.
Please go ahead.
Hello, my name is Alan Koch. I'm from In My Palm team, and we are determined to bring supply chain sustainability to your palms. With the renewed push for climate action, it is essential for organizations like Astra to ensure that their supply chain is sustainable. Unfortunately, Astra still depends on manual methods, and this makes them vulnerable to high operation costs as well as fragmented and inefficient supply chain. On the flip side, farmers are also price sensitive, and their loyalty is determined by who is willing to pay the highest price for their produce. This is unsustainable for Astra, since it leads to unpredictable collection volume as well as low margins. To address this challenge, we designed In My Palm, a blockchain-based platform that sources data from satellite, third-party data providers, to map out the sustainability score of every partner in palm oil supply chain. Additionally, to gain farmers' loyalty, we provide farmers with loyalty points, which can redeem to get free fertilizer and seedlings, as well as benefit from digital learning resources and the best farming practices that will result into higher yields. This is how it works. A farmer will simply log into the app and provide farm details like farm size, GPS coordinates. On our end, we'll use this information to source biodiversity, carbon footprint, and human labor data, and later aggregate them to come up with a sustainability score. When buying, mills and intermediaries can log on to the app, check respective farmers' sustainability score, and later reward them with loyalty points, in which they can redeem to get free fertilizer and seedlings. Currently, majority of the mills and intermediaries depend on manual methods to trace their supply chain sustainability, and this leaves them unable to both incomplete data and high fragmented supply chain. We take pride in the fact that In My Palm streamlines supply chain traceability while empowering local farmers to adopt sustainable and responsible farming methods. Additionally, In My Palm is not limited to palm oil. It can also be applied to map out gold, copper supply chain, among other products that Jardine deals with. In our solution, Astra mandates mills and intermediaries to buy FFB that was sustainably and responsibly sourced. And to accomplish this, they'll need to access farmer sustainability score on our platform, in which we plan to charge a fee to access. With adoption of In My Palm, Astra will be able to reduce the paperwork and human capital associated with manual supply chain and traceability, as well as save time, resulting into more than 60% in cost reduction. In the little time we've had, we've been able to define the business concept and design a small mock-up of a solution. And we are looking to build our prototype and pilot later in the quarter with Astra. And to see this solution through, we have Alan Okoth, who's a blockchain developer, Kaidiru, a sustainability consultant, and Almira, an industrial designer. Thank you. This is a video indicating how our solution works. So this is the place where the farmers enter their farm details.
All right, thank you. We can see that video. Sorry, go ahead.
The time is not ended. The time has not ended.
Sure, go ahead.
So this is the products that we are tracing. And so this for the supply, the palm oil supply chain, you include that if, for example, there is child labor, you'll get less ratings. For the intermediary, the sustainability score, and also for the milling factory and the processing plant. They all get sustainability score. That is, we assess their activities if they are sustainable or not. Yes, that is from us.
Thank you very much. Questions from our judges?
Yeah, thank you very much. Quick question. So is all the data self-declared, and for the non-self-declared data, in terms of data integrity, how do you go about it?
To verify that the data is valid, for biodiversity and deforestation, for that we use satellites to sort that data. And for data on human labor, that we have to go on the ground and collect that data.
And how? On the ground, so you deploy your own, yeah.
Yes.
Okay, thank you.
And do you have any IoT devices in the actual forests picking up any other sensors for you?
At the moment, the only IoT component is the one that's connected with the weighing scale, because at the moment, the process of buying the FFB is pretty manual, whereby the farmer goes to the intermediary, and then they are sent to weigh their produce at the mills, and then sent back to the intermediary. So our solution has an IoT component whereby once the FFB are weighed, they are transmitted to our system, and they are able to calculate the final buying price.
Thank you very much. Do we have any other questions from our judges?
Maybe I have one. Hi, Ellen. I'm just curious, how would you onboard the farmers? Assuming that farmers all their lives, they work on the farm, but how do you make sure that they become, relatively more tech savvy and be able to operate the app, and also recognize the sustainability score that you're going to be given to them? I just thinking about the onboarding experience of those farmers.
Will I be allowed to? I see my time has ended. Can I finish up on that? So at the moment, the farmers are very price sensitive, and they are looking, and they sell their produce to whoever is going to give the highest buying price for their produce. And so to try to tame them, we had the idea of loyalty points, whereby the more they sell their produce to Astra, the more loyalty points they earn. And we also factor in the sustainability score.
All right.
And so this will attract them, so that they try to ensure sustainable and responsible farming methods, since higher sustainability score means that they'll get higher points, and higher points means that they'll be able to earn fertilizer and seedlings.
Thank you, Alan.
Thank you, Alan. Thank you very much. Thank you for sharing that with us. All right.
Welcome.
Thank you. Thank you. We will speak to you a little bit later. And our final pitch of the day, you have heard 9 wonderful pitches. Our last pitch today is from another student, an innovator. And the business unit that has asked the question is Jardine Restaurant Group and Mandarin Oriental. And they would like to know, how can we reduce food waste in the F&B, food and beverage industry, and hospitality industry? And this was one of the more popular applications, definitely a very tough competition here. And we have a team brought to us from students in the US and the UK. The team is Team Sustaina. Hi, Team Sustaina. Hi there, we can see your screen. Hello. Hello, we can hear you as well. You have 5 minutes on the clock. Please start in your own time.
Thank you. Hi everyone, we're Sustaina and we aim to reduce waste from the top. From the analysis about the prompt, we have hypothesized two possible pain points that restaurants may consider. One is how much to order. Restaurants might not have sufficient data to inform them of how much to order of each ingredient to balance between freshness of food arriving on time to serve the demand, and having sufficient quantity for that demand, not too much that food will be spoiled and not too little that there will be a deficit. And pain point two, the inventory might spoil nonetheless. Raw ingredients that's left in the inventory might spoil, and this contributes to 21% of total food waste. This has significant business and environmental impacts. Environmental because spoiled food is less efficient and there's less possible options to manage waste. And it affects businesses because spoiled food has not been paid by the customer, whereas something like plate waste technically has no business loss since the customer has fully paid for the dish. So this is essentially free waste. Because of this, we have developed a modular system that covers these two pain points. Each of the box represents a module, a totally independent module, but of course, together they work in an automated and integrated way to help reduce the two pain points. Firstly, the software system comprises of these four modules. The predictive system actively makes prediction according to an algorithm in order to calculate the amount to order of each ingredient. This, combined with the just-in-time ordering mechanism, allows the system to recommend when to order as late as possible, because lateness not only ensures freshness of food when the restaurant needs it, but ensures that more data is available to increase accuracy. The system then notifies the IMS, the inventory management system, which is essentially the memory store of the solution. This system keeps track of inventory and displays inventory in real time. It keeps track of the expected deliveries, information presented from the predictive system, the expected stock level, and then calculates the deviation from actual stock level and expected stock level as predicted by the predictive system. This information is then used in the dynamic menu system, which calculates a sustainability score of each dish. This score represents the importance or the environmental impact of each dish on the menu. A higher score would mean if the customer were to choose that dish, they would have larger environmental food waste savings than one with a lower sustainability score. The dynamic menu creates this score using the deviations from the IMS and other data such as expiry dates of each ingredient, and then picks a selection of dishes from a list of possible dishes to be put on that menu, and this updates daily. There's also a reservation system, which is already commonly in place, but this one is fully integrated with the other modules and provides additional information for the predictive system. The other non-technical, more behavioral sides uses research-informed nudges. We add to the dynamic menu system the sustainability score presented in an easy-to-see and clear way to help customers gauge different dishes and how sustainable it might be to help with their choices. And there's a possibility to add dynamic pricing to each menu. So a menu with higher sustainability score would be 10% less in price, for example. The score itself can also be tracked live, real time by the waiter staff. And because it changes hourly, the staff can be incentivized to recommend dishes with higher sustainability scores to customers to help get those dishes out and reduce excess supply. There's also seasonal menu creation, which is essentially creating a menu at the beginning, which incorporates a variety of ingredients so that the dynamic menu system can incorporate it together in each daily menu. The data points we'll get as follows. These are all available for the restaurant managers and the chefs to see. Taking a look at a short demonstration of a case study, first the customer orders through a dedicated app. They can pre-order so that the dynamic system knows what to expect and how to distribute each supply in the future. When the customers arrive, this is what I was mentioning, the sustainability scale presented as dots to help show more sustainable dishes. And when they order, this is when the staff can help recommend dishes according to the real-time tracking shown by the dynamic menu system. And at the end, there's a little feedback to help regular customers come back and continue to minimize waste. The implementation system is very easy to implement due to customizability.
I'm going to have to cut you off there. Apologies.
Of course.
All right, judges. You have 2 minutes to ask your burning questions. Go ahead.
Well, I think if you can continue with that slide, because that was one of the questions on how do you implement it on the customer side.
I'll talk about these steps here. So because of its modular system, we'll have to first discuss with each restaurant what their needs are, what their objective, what their goals would be, the demographic, for example. And then we would continue to customize and install the solution. And this would include manual customizations that are made to the code base to match the restaurant's needs, and the installation of the relevant data collection systems. There'll be a next step where the system is trained using data from that particular restaurant so that the whole system can be customized to that particular restaurant and its patterns. There's the next step, which is system refining, which is where the system is switched on, but it's still closely monitored. So this is where the system begins to actually provide a score to use. And in the end, we have a fully functioning holistic solution.
Hi, if I may. Yeah, hi, this is Kathy. I just wonder, so this is a solution to address the food wastage, right? Will there be any difference when it comes to system design, logic design, if this application or this system, this solution is being offered to, say, KFC, which is a fast food chain, versus, say, Mandarin Oriental, a 6-star hotel, that's not going to have, they're going to switch manual, like maybe every other month. So, there is a lot of customization, maybe. So I just wonder if you're, what tier of restaurants or F&B outlets that you're addressing, and how do you accommodate different tiers of, potential customers?
So the system we developed is a modular system. So that means that even though it works well together, each restaurant can look at it and say, this part we already have a system for, or this part we don't really have to implement, and they can implement the parts differently. And each part are also designed so that you can just give it an input, and it will always try its best to come out with the output. So during the initial discussion phase, we can go through what the system can do, and we can try giving it some data to see if it matches your business or not.
I guess maybe it's food for thought, because your system training takes 3 to 4 months. So in some cases, they may, you may need to tweak or tune or, just branch out different modules in order to go to market.
Thank you very, very, very much.
Thank you. Brilliant idea. Yes, I love it.
Teams, judges, we have done something incredible. We have listened to 10 fantastic speeches. We will now cut to a break. Audience members, we are going to put our judges into a room where they will have to deliberate and pick one student winner and one startup winner. So in that time, please stay tuned. We're going to put some heat on the judges and cut the intermission, and we will be back here in 20 minutes time at a 6:30 sharp start, Hong Kong time. So audience members, please stay in the chat, say hi to us. We will chauffeur our judges away now. Thank you very much. We will see you shortly.